Tomorrow night at midnight, let's drink a toast to your birthday. Will you remember?
I'll drink, all right.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for a show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Daniel Theobald, who is the CEO and founder of Vecna Robotics, an autonomous material handling solution startup. Thanks for joining today.
Thank you for having me.
So I was very impressed as I was digging into your background. You are a prolific inventor with some 97 issued and pending patents. So the question I have is, when did you realize that, research, specifically robotic, was such a passion for you as well as the invention component?
Yeah, it really has been a lifelong pursuit for me. I had the great fortune, I didn't realize it at the time, but I had the great fortune to grow up in Silicon Valley, really before it was even called Silicon Valley. The elementary school I went to was one of the first elementary schools in the entire world to have a computer lab. We had Commodore PET computers and Apple I's. And just got this amazing exposure to technology that really, even today, I think is not super common. And that just set me on this path. I've been passionate about computers, electronics, mechanical engineering, all of which come together, of course, into robotics since I was a child. And was very fortunate in high school, actually, to be chosen as the top computer science student in all of California's high schools, and got to go to the Lawrence Livermore National Lab and work on the fastest computer at the time, the fastest supercomputer, which was the Cray Bubbles computer. They called it Bubbles because this entire computer was submerged in water to try and keep it cool. And got to interact with some really amazing scientists there. Got to meet Edward Teller, had some discussions with him that had a big impact on my life. Edward Teller is the somewhat controversial figure, father of the hydrogen bomb. And, just have been on a constant path towards trying to build technology that helps humans live better, fuller, more productive lives.
So I want to go back to your introduction because, when we think about Bill Gates' story, and of course we know where he ended up even after he retired, is that there were some hidden advantages in terms of his ability to have access to, sizable computers back then that, frankly, not a lot of other, people of his age had easy access to. So I think clearly the access and some of the familiarity that you've had, and of course your ability to rise to top of the top really says a lot. And certainly I get the sense that you're really pushing the boundary, and that's what your company is doing as well. We're going to come back to a point that you made, which is around this notion of helping humans and this notion of working together with humans, which I think is a very important theme. So let's get into the Vecna Robotics. What is it, and how is it applying robotics in distribution, warehousing, and manufacturing to be able to help streamline materials handling and logistics?
Yeah, Vecna Robotics is industry leader when it comes to autonomously moving material around in industrial settings. So warehouses, manufacturing plants, retail organizations, distribution centers, anything where you need to move items from point A to point B, we're able to do that autonomously. We have a wide range of robotic platforms, from large platforms like forklifts that can move large large amounts of material, all the way down to small robots that can very quickly move single totes or cases. And the approach that we took really is unique in the industry. A lot of robotics companies, when robotics became exciting, which is fairly recently, would build a robotic platform and then write a lot of software specifically for that piece of hardware to do something useful. Over the past couple of decades, instead, we've solved the much harder problem of general purpose autonomy. How do you build a system that can learn to drive any piece of equipment, much more like a human being might do that? So instead of having to have a bunch of software engineers write a whole bunch of code for each new platform, we're instead able to just configure our system to drive a forklift, drive a tugger, drive a bus or a tractor or any type of vehicle. So very different approach there. And that has allowed us to move very quickly. When we spun Vecna Robotics out of the parent company in 2018, we very quickly became a world leader because our technology is so adaptable. The type of feedback we'd get from customers is, wow, yours actually works. We'll take these. And that's because it's really hard. Building robots that can work effectively in the real world 24/7 safely is a tall order. And there's a lot of non-glamorous work that needs to be done there.
Yeah, I think just in that last couple of minutes of you explaining, I'm just thinking that behind it, there's probably mounds and mounds of technical journals, and of course your proprietary recipes in terms of the IP stack that you guys have built. I mean, it is no small feat whatsoever. It's actually monstrous in terms of what you guys have been able to achieve. This goes to the question I was going to ask, which is, why is it that you guys have stood out, been invited to participate in the spring batch of the MIT STX25 Startup Accelerator, as well as being named the RBR 50 Robotics Innovations Awards winner by Robotics Business Review, as well as being recognized by Supply and Demand Chain Executive as one of the 100 top supply chain projects of 2020. So clearly, you guys are doing something right, and I think that the industry is responding to that. And what is very interesting is that we are seeing so many permutations of different robotics, even in the warehousing space, as an example, as more of the shopping malls get converted over to essentially fulfillment centers or something to that extent. Mm-hmm. We're going to see a lot more use of these types of robots, but the application, the uses are so different from size, weight, and all the feature set. Right. So being able to actually work off a same chassis in terms of OS, essentially the firmware and the software, that's pretty astounding. Can you talk a little bit about kind of the system, because the system is hardware, software, firmware. I mean, it's everything, right? Yep. And then how do you then adapt it to the different things of various scale, from the smallest robotics in a warehouse to the largest agricultural tractor?
Yeah. So what we did over the past couple of decades is build a software platform. We call it Pivotal. The Pivotal software platform really does three things. You can boil it down. One, it allows us to turn any piece of equipment into a fully autonomous, safe mobile robot. There's basically a black box. We call it the autonomy kit. We bolt that autonomy kit to a piece of equipment. We connect some sensors so that the robot can essentially see the world, and it's a robot. It's not quite that simple, obviously, but that's more or less how it works. The second thing that our Pivotal platform does is learn. Really focuses on learning. As a matter of fact, I think one of the biggest differentiators that we have is that our systems learn and improve very quickly. When we deploy a system at a customer, typically it does pretty well day one, but it gets better and better over time. This is different, of course, than traditional products, where you would buy the product and you take it out of the box and it's shiny and it's new, and then over time, it gets old and it degrades and it doesn't work as well. Our products literally get better the longer you use them. And so this is really valuable for our customers to understand, because when they're making that decision, that buy decision, what they know is that they're not just getting something that will meet their needs today, but they're getting something that will evolve with their business needs over time. And this is crucial now. One of the number one things we hear from customers from the industry as a whole is flexibility. Prior to some of the crazy stuff that's been going on in the world recently, you could perhaps think that you could design a warehouse and it would operate largely the same way for 5 or 10 years. That world is gone. That's not the world we're living anymore. The rate of change has increased so drastically that customers can no longer invest in fixed infrastructure type of solutions. They need something that can adapt. They need something that can be resilient to change. And so this idea of having mobile robots that are by their nature general purpose, you can use them for lots of different things. It's not a purpose-built special machine. Have that technology be able to learn and adapt as conditions evolve, ensuring the value proposition. And then the third thing that Pivotal does is orchestrates the robots and the humans to work as effectively as possible together. And this is probably one of the biggest value propositions we bring to the table. What we found early on is that robots are just as good at wasting time as human workers are if they're not tasked appropriately. There's no magic, right? Robots aren't this panacea of perfect efficiency. You need to plan, you need to execute that plan, you need to react in real time as the plan needs to change in your warehouse. So the Pivotal orchestration engine, it's like a grandmaster chess player. It's sitting there, it's looking at the board, it knows the goals because it's integrated with whatever the upstream system is, the warehouse management system, the order management system. So it knows what it's trying to get done, and then it understands the resources that it has available to get that work done. The robots, the manually operated equipment, the human workers in the system. And it's able to, in real time, help to make those task assignments, but not in a way that not in a way that turns humans into robots. And we've seen some of this in the media recently, where there's worry that we're treating our workers like robots. The whole goal of Pivotal and the value it brings is that it allows the humans to really do what humans are good at and what they enjoy doing, and it allows the robots and the automation to focus on the things that they're good at. Together, you get a far, far better result. And so that's really the overall approach. Turn any piece of equipment into a robot, have it learn and improve over time, and make sure that then we're using all this data that's streaming in to optimize operations in real time. And what we've been able to show is over 2 times increase in throughput without adding any additional resources, just by making sure that you're fully leveraging the resources you already have.
Yeah, I'm actually not surprised by that statistics at all. I wanted to kind of echo and point to something very specific, which is that earlier part of this year, because of the pandemic, there was some serious disruption to the supply chain and logistics. So when you think about, let's say, the pork industry or the poultry industry, and just general, I think, scarcity and issues around just distribution of things. So that's a perfect example where I think these large corporate entities that were accustomed to doing business in the same way had a hard time actually pivoting and being able to be agile and work with less, maybe on the input side, but also work with less on the output side, including trucking capacity. So it's very interesting to position this in a way that it's very adaptable, and certainly as we see with trends around e-commerce and continue retail going online and so forth, that this notion of how we use space and how things get fulfilled, how the last mile gets delivered, it's changing very rapidly. It really is, and I think there's going to be a bit of a permanence even after this pandemic. Can you talk a little bit more specifically about how maybe one of your clients have really kind of exemplified what you're talking about in terms of that flexibility, as well as working with limited resources, but again, allowing for humans to do the best while the machines continue to increase the throughput?
Yeah, I'll highlight two things. Fedex is a public customer of ours. Many of our customers are not public because they like to keep their innovation work under a little bit of cover. But we worked on a project with Fedex. We deployed some tuggers in one of their facilities. They thought that facility would continue to operate the same way it had been. But the world changed and they realized that they needed to repurpose this facility. The conveyor that had been built into that facility was largely lost. It's big, built-in, bolted to the ground infrastructure, not easy to repurpose that for the new project. Our robots, on the other hand, they were able to put them on a truck and take them to a new facility where they could continue to provide value. So that's kind of the idea here. Built-in, big infrastructure just lacks the flexibility and resilience that mobile robotics and human beings do.
That's amazing.
Now, yeah, and I'm not saying that conveyor is not great. Conveyor is an innovation that has moved industry forward as much or more than many other things. But there's a trade-off, right? There are always these trade-offs, and in a well-designed system, you're going to appropriately balance those trade-offs. Now, the human factor is super critical. And this can't be emphasized enough. I think a lot of times the problems that people run into in deploying the technology is they expect too much from the technology. They've seen a lot of Hollywood films. They think robots are this amazing, magical thing that actually have human levels of intelligence. Spoiler alert, they don't. Elon Musk ran into this problem. He talked about in a fairly famous tweet, talking about a failed automation project. He said, I failed. It was my fault. It was my mistake. I tried to over-automate. Humans are vastly underrated. And I think when we try to jump too far towards lights out automation, people are the problem, let's get rid of people, we're really misstepping. People are amazing. But on the flip side, there's certain jobs that people don't really like doing. Some of our customers have talked to us about their challenges with staff, and some of them have talked about having over a 300% turnover, meaning every year on average, they're having to rehire and retrain their staff 3 times in some of these facilities. And that's obviously not good for anyone. And we say, well, why don't you raise wages? And they say, we keep raising wages. That's not really the issue at the end of the day. It's that the type of work is not something that humans really enjoy. And so when we were introducing robots into one of these facilities, it was really interesting to see the reactions, because we brought some of the staff in and we said, here's this robot. This is what we're going to be doing. And someone got their hand up and they said, oh, robots. So we're going to be replaced. When are we getting our pink cards? And a very thoughtful manager at this company said, as a matter of fact, the robots aren't here to replace you. The robots are here to help you and to make your job better. Why? Because we want to keep you. We want you to enjoy your work. We want you to be able to do the type of work that really provides value. And we're going to let the robots, sort of take the parts of the job that you don't really enjoy. And so it's that coupling of the human and the robot that has always been the way that humanity has moved itself forward, if you do it right. We think of robots as a special case, but they're really not. It's just another piece of technology that helps us to get more done. It used to be back 100 years ago that 70% of the population in the US was engaged in producing the food that we eat. Now it's less than 2%. I think latest I saw was 2.3% or something like that. And I don't think anybody's complaining about loss of farming jobs for people, right? Because it has created this opportunity for all these amazing other things that the human race can do. So I think that balance in making sure that we're not throwing the baby out with the bathwater. Humans are amazing. We need to take care of humans. Humans are the point. Let's use technology to make life better for humans. Ultimately is what gets us the best results and gets us the best economic results too.
Yeah, I'm sure, for your industry, that fine balance and making sure that the messaging is properly conveyed to the public as well as the potential clients is very critical. So I appreciate you spending some time. I wanted to explore a little bit in terms of kind of the nuances, because I think there's a lot of sophistication and just technical challenges. Maybe if you could just share one or two things along the kind of the journey that you guys been able to kind of solve, but or maybe even refine still, and how you've been able to kind of get around creatively around some of those technical challenges and problems.
Yeah, this is a really interesting question. My thoughts just went back to a project we did many years ago. It was a military-funded project, and we were sitting in the room, and the military representative was there, and he said, "And I'd like your robot to be able to pick up that glass of water." And I said, "Well, that's really out of scope of this project, and that's a incredibly hard problem that is a focus of a lot of research." And he said, "Well, why? We paid for cameras, so clearly the robot can see it, just tell it to pick it up." And it's hard as a human being to understand how amazing the human body is, how amazing our eyes and all of the visual processing that goes on before it even gets to a conscious picture in our head. At the end of the day, a camera spits out a series of numbers, and that's it. It's our ability to recognize things and to understand the world is so far beyond what any technology can do today or will likely do for the foreseeable future. It's easy for people to not totally appreciate the amazing complexity of what we're trying to do when we try and make a robot operate autonomously in the real world. So this machine vision problem is quite complex. Being able to identify a pallet, for instance, a human forklift operator sees a pallet. They see the pallet pockets that you put the forks into. It all just makes perfect sense. It's easy. Trying to get a robot to do that reliably and safely is an incredibly difficult challenge. We have over 60 million lines of code, 60 million lines of code that people wrote to make our systems work reliably, safely in the real world. So it's just a tremendous engineering challenge to be able to see what you need to see. And I'm air quoting seeing because the robot never really sees. The robot gets a stream of numbers and you have to do a whole bunch of math to turn it into a plan. It's just absolutely amazing. I'm so proud of our engineers here for what they've been able to accomplish. And that's also why I think it's really important that we really improve our STEM education here in the U.S. The number of people that are graduating with the type of skills we need to really continue to move forward in some of these areas is just not quite keeping pace.
Well, I really appreciate you taking a moment to allow for us and the listeners to really kind of appreciate the complexities that's involved, and I think the kinds of things that we take for granted as humans and our abilities, and somehow we tend to easily just transfer that to objects like robots, thinking that they can do something similar, when in fact there's a lot that's involved. And I could just imagine you guys probably have to train the system to understand the various conditions of pallets, not only the kind of materials, but what if it's damaged, what if it's pieces missing, or the colors, and lack of uniformity between pallets and so forth. So
Yeah.
Fascinating. Absolutely fascinating. We are out of time, so I wish we had more time to ask your questions. But if you could, within 30 seconds, answer this question around lessons learned. Any product or project or technical challenges that you guys and the team have worked on, and the lessons learned that you can share with others.
Well, I'd say the number one lesson learned I'd give to entrepreneurs is learn fast, fail often. The idea that you're going to go off and build something in a vacuum that's going to make a difference in the world is generally not the way it works. So really important, if you want to make a difference, you need to engage in the real world with real customers that have a real need, and be willing to fail, and learn from it. Our approach at Vecna is learn faster than anyone else, and you can't do that if you're not making a lot of mistakes.
Well, that is the definition of scientific discovery. So with that, I've been joined by Daniel Theobald, who is the CEO of Vecna Robotics. Thank you for joining today.
Thank you.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.